Hello there. Well, that was a bit of a struggle trying to get all of that sorted out. Seems YouTube has changed its streaming system again, so doesn't like going through Restream or third-party services, which makes this all very awkward and time-consuming to constantly keep setting up. Anywho, so today we're going to make a Halloween item for IMVU. Going to make a pumpkin, well, a pumpkin something or other. It's a furniture item. So what we're going to do is start with the furniture file, which is that one. Drag and drop. And then just start modeling. So we don't need that. Don't need the ceiling, don't need the wall. Keep the floor. Right, so we need to make a pumpkin. I wonder if, let's try a different way of doing this. Add modifier, subdivision, whoops. That means that the edge split modifier is at the top of the stack. So that's taking precedence over the subdivision. So if I remember correctly, we can shove this down to the bottom. And it means the subdivision becomes the precedent of the stack. Let's just wireframe that. Do we have wireframe enabled? Oh, and we're using 2.83 LTS for this. So for anything to do with IMVU, it's recommended you use the long-term support version of Blender, not the current active version, because it's stable. If you use 2.9 in any version going forward, there's no guarantees that it's going to work the way that it should, so it's best to download 2.83 LTS. Right, so we have wireframe enabled. We don't need sharp for now. I wonder if that's enough. Let's try that. So we're going to apply this modifier. So that we actually create the structure. So when we switch to edit mode now, we actually have a sphere instead of a box. Because whilst the modifier is active, the spherical shape is being generated procedurally, not physically. So we have to, if we want to edit this and to produce our pumpkin, we need to apply the modifier. That gives us the structure that we need. So what we can do, best way to make a pumpkin. Actually, this won't work with this, will it? Because what we really need, we need this to be the focus, and we need the structure of the pumpkin to fan out from that point. Because, so let's just move that to one side. So we're going to drop in a sphere. UV sphere. We don't want it that heavy. So in the panel, whoops. Let's try 16. Oh, that may be too many. Try 12. Nope, that's not enough, because what we want to do is select so that Shift Alt right click if you've got your right click set up, because what we can do is looks like one of those lantern flowers. That's interesting. Never noticed that before. If you do a scale, press the S key, just uniformly scale. With this type of shape, scaling like that behaves the same way as scaling along the normals, so that's Alt S. Whoops, degnum it. It does the same thing. Never noticed that before. Anywho, smoothing. Let's try inverting the selection, so that's Control I. Very simple pumpkin. Let's get the stalky bit. Extrude. Yoink. Scale. So we don't necessarily want this many sides for this, so we can do one of two things. We can either collapse. Well, there are a couple of ways of doing this. We want to get rid of every other vertex. So we can either mesh, delete, dissolve vertices, which gets rid of them, or we can do them individually, double tap, that gives us a slide so we're reducing the number of faces, or we can use snap. So we select our target first and the object to be snapped to it, and then it's not the M keys. Oh yes, it is. Oh well, it's merge. So what we can do is snap selection to active. Whoops. Oh, it's the other way around. So if you use merge, we have the options. So it'll merge to the first thing that was selected, but if you use snap, you want to select your target last. The difference between the two is that merge gets rid of the additional vertex that's created. So that's the M key. Or mesh, where is it? Merge. Mesh. So because we've used a couple of different ways of doing that, we need to get rid of coincidental vertexes. So because we edge slid these vertexes together, we've got two vertices in the same place. We want to merge those, so select all, mesh, clean up, merge by distance. That gets rid of those. And what we might need to do sort out these faces. Now this is in face, triangulate faces. Right, so that's our basic pumpkin. Let's just add a quick material and UV map to this. So select, new, zero square brackets, zero close square brackets. For the moment we can use viewport display, change its color, do a pumpkin color, then what we can do is set up shading. Where's our pumpkin gone? There it is. Add texture, image texture. Just connect color to base color. Click new. We want pumpkin. And this is just temporary so that we have the basics set up. So that's 512 by 256. Color grid. Okay. So there's our basic texture. So this will all change when we start doing a bit more editing. So we can see it because the object by default has a very basic, whoops, scale. I have to keep resetting these views because Blender doesn't keep the same values for all of the views, so you have to keep resetting them when you change the workspaces. So different workspaces use Blender's defaults, which basically means that the clip distance of the camera is quite shallow because the scale difference between Blender and IMVU is about 100 times. So whilst the scaling works fine for Blender stuff, when we bring in our IMVU stuff, we find that the camera clips everything, so we have to keep setting that for the different views that we use. So we do that in the view, go away shortcut key, tool tab notice, so sidebar, and then in the sidebar we want view, and then we change the clip start and clip end. So generally speaking, for furniture items, it's just going to be 2500. That's more than enough. Clip start, that's optional, but just change that to 1. So now we can rotate around the scene and we see the whole object. Right, so the object is UV mapped by default because all objects, primitives, contain a basic UV map. For an object like this, a sphere, it's basically that. So let's just get that using the correct image. So that's what it looks like by default, but all of that's going to change. But we'll leave it like that for now. Because, right, so what do we want to do with this? I'm going to move the avatar into place temporarily, because we're going to scale this up. All 3 axes. So we have to left click, drag anywhere inside the white outline, and it'll scale up on all 3 axes. That's a bit big. That'll do, because what we want to do is use the, let's move the seat node out of the way now. I'm going to use this to extrude a set of handlebars. Let's just get rid of that center. Vertex. So mesh, delete, dissolve vertices, and that'll cap So we've now created a cap across that structure, which we can now select. Hang on, let's put the avatar back into place. So what we want to do is, whoops, extrude. Just hide the standing avatar. I have to use the shortcut key, which is E, just to make this quicker. So we want to make a cut in there somewhere. Let's just hide sitting for now. Let's do a bit of shaping. So let's do going to edge slide these two vertices, because what we want to do is basically create a cut like that using these two vertexes as this bottom edge. Knife tool, which is the edge slide? Oh, there it is. Taking a bit. There we go. Knife tool. Enter. So that can be a little tricky, but if you use the tool, instead of pressing the K key, K for Kevin, you don't get a highlight indicator as to when the knife tool icon, oh, you can't see it when that's active. So when the knife tool icon is active, you don't get the highlight if you use the tool, the toolbar icon. But if you press the K key, you do. So you get that little node popping up, so you can see when the tool is actually over an edge that you're actually wanting to cut, because it highlights it. It doesn't do that with the tool. Which one is it? That one. It doesn't do it if you use the tool icon, but it does do it if you use the shortcut key. So keep that in mind. There are one or two other differences between the initiating the tool using the shortcut key versus the tool icon, but either or, whoops. So double check that that hasn't created duplicate vertices, which it often does do. And it hasn't, that's okay. What I'm going to do is just extrude. Extrude. Just very crude extrusions, because we can shape that next. So we're using the shortcut keys, number 1, vertices, number 2 for edges, number 3 for faces. It saves constantly having to click the icons. And I'm using the shortcut key G just to move things. And then what we can do is now start shaping things. So let's unhide the so what we want is the avatar sat on the pumpkin, but not too close to the handlebars. So loop select, whoops. We don't actually need this many faces for structures as simple as this. So we could probably reduce them. Whoops. In fact, let's do that. So what we want to do, we're going to reduce this to a 4-sided surface. Right now it's 1, 2, 3, 4, 5, 6, 7, 8. So we want to reduce this down to that, but we don't want to actually do it so that it's a square. What we want to do is this, because we can create the illusion of a rounded surface because of the orientation of these cardinal edges. Because they are off rotation relative to a square, we generally speaking don't see these. We don't see this when it's rotated as a square like we would do with this one, because we're looking at it face on, regardless as to which orientation. But when we're looking at them from edges, the surface, or the object or the shape, looks round, it looks smooth, particularly if we have smoothing active. So we can create the illusion of round or smooth surfaces and still have a very low resolution mesh. So we want to keep this top edge and just, so what we'd want to do then is collapse these two so we can use at center and go all the way down. Even down to the bottom here. So that's the front side. So we want to do that on the back side, which is these two. All the way down. Let's hide the sitting avatar again. So that then means what we can do, so that's the front, that's the back, so we just want to collapse these, so that's the 2 edge loops on the top and the 2 edge loops on the bottom. So select vertexes, collapse, at center. We don't necessarily need to go all the way down to the bottom, so let's leave this for now. So we've stopped there. We don't need to collapse these 2 just yet, just going to see what that does. So the top. And we could probably do the same, we'll carry that across. So we'll do the same thing on the other side. So what we're going to do is carry across this structure that we're creating, or this reduction. I'm going to carry that across up onto this side as well. And we're doing it for the same reason. We don't need a complicated structure for this. So at the bottom, so that's those 2. And again, we'll stop there and leave these 2 as they are. So it's those 2. Whoops. These 2. I think actually looking at that, with it being so low poly, we could probably get rid of some of these edge loops around the pumpkin, because they don't necessarily add any particular detail to the object. We'll get back to that later. Look at so we can start adding loop cuts. So the shortcut for that is Control R, or we can use the loop cut tool. And we can just start playing around with the shape. So it looks a little bit more twiggy and irregular. Let's do whoops. Let's make these a little bit more substantial so they don't look as if they're going to snap. Let's do so this is going to be very uncomfortable to ride. So there's our handlebars. So let's just save this. Whoops. I'll save as. furniture. Right, so let's take a look at reducing some of this. So one of the disadvantages of using the mesh primitives is that they tend to add a lot of structure that we don't necessarily need. So with these types of shapes, it's adding a lot of structure, doesn't really do anything. I mean, you can add it if you want, but it doesn't do anything in terms of describing the shape. Because if we look at the object, so this is the profile that we've got, and it's basically a series of linear surfaces or edges. So when we're looking at the object, we're not actually necessarily seeing these edges that are in here. We don't necessarily see this structure because it's not obvious to the eye what's going on in here. But we do see the profile. And that gives us an idea as to how, detail is the wrong word, but how much mesh structure the object actually contains and how much of it we can get rid of. So, for example, if we watch this section of the mesh here, so this is this edge loop that goes all the way around. So this edge, or this shape, the profile that's being described here, is being described by two edges. And it's quite a subtle curve. So if we select that, so if we keep an eye on what this edge does here, if we select that edge, just get rid of it. No, it's delete. Delete. Dissolve edges. We can see that it changed, but not by much. So that edge that we had in place doesn't necessarily describe, or it doesn't help in describing the silhouette or the profile of the object. So that's how you can tell when you've basically got too much structure. If the structure that you've got isn't actually doing anything in terms of describing the shape of the object, then just get rid of it. Particularly because IMVU is a low poly environment where we need to keep control over our meshes as much as possible. We need to keep them as low resolution as we possibly can, whilst at the same time describing the shapes that we want. So for this, what we could do is get rid of that one. Delete. Get rid of that one. I'm going to use the shortcut key, which is X. Dissolve edges. Get rid of that one. So we're keeping the middle of this object. Dissolve. Dissolve. We might need that one at the bottom. Or maybe not, we might be able to get rid of that. So we've basically just removed all of those edges that were doing a lot of, well, they were subdividing the mesh quite aggressively, relatively speaking, but they weren't really needed. And what that means is that by getting rid of those edges, we now have more structure to play with to describe other elements or add more detail elsewhere. So for example, if we wanted these was going to say flutes, that's not the right word, but these concave shapes, if we want those to be less aggressive, we could use the structure or the allowance that we've now got by removing those edges all the way around there. We've given ourselves some more structure that we can play around with to then, let's say, select those, split, subdivide. So that now gives us a bit more structure that we can play with to make those corners softer. We'll have to play around with that a little bit because we're off kilter. So let's go to local, or is it normal? Local. And we can do that selectively around the mesh. Subdivide. Whoops. And it rounds off those pointy profiles, makes them smoother. But because we got rid of those edges that were not really doing anything, we can now use the allowance that we've got to add more structure or more detail. So we're doing a scale along normals, so that's the Alt S key, because what we want to do we want to try and avoid too much of the scaling based on it'll be median point, so it's scaling uniformly in all directions relative to the selection. So if we use scale along the normals, what it's doing is scaling each selection along a particular direction based on the orientation of the edge. So that's Alt S versus S, which is just scaling relatively in all directions uniformly. Whoops. Alt S and squash it down a little bit along the normals. Well, it's local orientation, so that basically means that the widget and the way it's manipulated is relative to the selection rather than the orientation of the scene or one of the other options. Edge, subdivide. Squash that down a little bit. Oops. I'm going to do 2 more to go. 1, 2. So there we now have something that looks a lot more pumpkin-like. Stereotypically, of course, because obviously not all pumpkins look like that. Hashtag not all pumpkins. Faces, let's triangulate these. Let's see if we can sort those out. Because what we've created here is an n-gon, or a series of n-gons. So that's surfaces with more than one, because what would more than one face, because what this has done, whoops, so with an n-gon we've got a surface that has more than 4 sides. So there's an edge that starts at this corner. Now Blender doesn't, well, this is generally applicable to all 3D applications. It doesn't know if that edge is supposed to go in that orientation or that orientation. And this matters because if it goes in one orientation, so we've got 2 sides of the same structure. So we've got this face on this side, got this face on this side. So this edge from this corner, it's like that, and from this corner, I think it's going that way. And what that does, oh no, it's going the other way. So it's collapsing. So it's drawing an edge like that. So our edges are orientated that way for that face, and that way for that face. So there's an edge here as well. But the net result of that is that this is a convex, convex, and that's a concave shape. So what we end up with is a dip in the surface here, whilst Blender is trying to resolve that side, whereas we get a rise on this side with Blender trying to resolve that side. So we have to convert these to triangles. Mesh, oh no, it's faces, triangulate, because that then allows us the ability to properly orientate the edges to get the structure that we actually need. And often Blender will it'll assume, when it triangulates the surfaces, it'll assume the orientation. So the way that this was actually being drawn before we triangulated was with that edge orientation. I don't know how easy this is to see on screen. But when we triangulated it, it flipped it. So the correct orientation, that's what we actually wanted. So what we can do, go around the mesh, double check our orientations, because what we can then do is join Alt-J, some of these together, just to tidy up the mesh. So I'm just going to shortcut key. So that's Control T, triangulate. So what we should end up with is a fan for this curvature of these sides. So each of these should be like this. And then what we can do is join these. Because these are basically planar surfaces. That basically means they sit so that's a plane, planar. So if we have that, if the two edges or the two faces are orientated along the same plane, or axes, I guess you could call it, we can join them together so that they form a solid face. Right, do that on the bottom. So again, we want the faces to fan out from this point outwards. Now we can join these planars together. There's no particular reason for doing this other than it just makes it easier to see at a glance exactly what part of the mesh is describing what structure. Let's just make some adjustments. Right, so there is our pumpkin. That's with the avatar sat on it. Right, so we need to save this. File, save as number 2. So in the next stream, so that's what we've got so far. So in the next stream, what we'll do is take a look at adjusting the UV map. This works, but it's not optimal for what we've got. So for the magic pumpkin, we need to redo the UV map so that we account for the handlebars that we've added, so that we can map that, or those, the two bars, we can map that to the same image. So we're going to probably have to use some space in here somewhere to map the handlebars. So in the next stream, what we'll do is take a look specifically at UV maps and editing those and getting all that sorted out. And hopefully by then actually have a texture of a pumpkin to hand. So we shall see you on the next stream. Right, thanks for looking everyone, and we shall see you anon, as they say. So bye for now.